Hey there, I'm Channel Technical Agronomist Matt Nelson, coming to you for part 3 of our year in review video series. In this video, focusing on the last part of the year, on August, September, and that harvest time frame. And just to recap what the weather was like then, August was warm. We had a lot of high temperatures and lack of moisture, at least that persisted through June and July into the first part of August before the temperature finally cooled a little bit as we got into late August into September. And we started to pick up some moisture in the form of fogs and dews, and depending on where you were at in the state, a little bit of rain. But in general, it was still fairly stressful through that latter part of grain fill. That led us to some questions. One of the biggest ones I got from customers this fall was, why did it take some products forever to mature? Matt, you just told me that stress after pollination can speed up that grain fill period, and it can, but the answer is that we really slowed down our GDU accumulation. On the right here, you see a tweet that I put out talking about why this was happening, as I had gotten a few questions about why everything seemed to be paused at about a quarter milk line. And if you look at this chart here, you see this purple line is our GDU accumulation for this year. And you see you had that dotted line is the projection. You had the comparison to 2021 and the orange line. Essentially what you're seeing is that when we got late in the year, our GDU curve really started to flatten. And think about how much late planted corn we had, right? A lot of late May planted corn, especially here in central Iowa. That meant we were accumulating fewer GDUs. The temperatures were lower. We even had some cloud cover that affected radiation. And we just sort of ran out of gas at the end of the season. And that affected dry down on some of these fuller season hybrids, and really any hybrid that is typically slow to dry down. This made it much worse. Okay, another grain fill question that I got. Why did we see droopy ears? So I started to see this and hear reports of it from dealers in August as we got into September, where a lot of hybrids had ears that were pointed down. The husk could have been either green still or it was brown, but regardless, these ears were a long way from maturity. So there are a couple of reasons for that. So first is loss of turgidity in the ear shank, and that's due to stress. Also, it could be caused by cannibalization of the shank if we're really stressed. So you have the main stalk, right, which is the main channel to get water and nutrients moved up through the soil and throughout the plant. The shank is essentially a mini stalk, right? It's an extension of that stalk. Nutrients move in kind of in a similar manner to the stalk, and that shank is just what connects the ear. And when we have stressful conditions and that plant thinks it needs to start cannibalizing nutrients from the stalk, it can also do that from the shank. Again, the shank is really just an extension of the stalk. And when that happens, you can get a collapse there where it kind of pinches in, and that causes it to collapse. So that can affect black layer. It can cause products to black layer prematurely. And we saw a little bit of that in 2022. I got a lot of questions about that. How does that impact yield? Does that impact dry down? And the answer is that if we're at about half milk, so R5.5 is what we call it, we can see about 12% yield loss. If we're really at early dent, then it can be more like 25%, right? As soon as that dent layer starts to form, I always tell people we're essentially 70 to 80% baked from a yield perspective. So there's still 20-ish% that's hanging out. Death at our, closer to full milk full milk line doesn't really cause any impact on yield. But one thing that we can see are shallower kernels. We could possibly see lighter grain overall. And one thing that we've noticed is that this grain tends to dry down very slowly. It's not that it won't ever dry down, but it seems to take a lot longer than normal if it black layers prematurely. A couple other questions. Did we see any sort of difference in yield by soybean maturity? And the answer is yes, and this has been a trend that's been ongoing, in my opinion, for the last 3 or 4 seasons. So there has been a trend across the state, and I think across the Midwest in general, to move to earlier maturing soybeans. So instead of planting a bulk from 2.8 to 3.2, we're planting 1.8 to 2.4, right? That seems to be a pretty common trend. Some of that is just due to the ability to harvest early, But I think if you talk to a lot of farmers, they'll say they're getting the same exact yield out of those earlier soybeans. And I'm here to tell you that the last 3 or 4 seasons, that has not been the case. So for those early planting dates, we're talking late April or early May, planting fuller season beans had a larger advantage. When I say full season, I mean in general 2.7 to 3.3. Reason for that is if we're planting them early, right, and we're getting more growth, we're getting maximum vegetation by the time we start flowering. And if you're planting a fuller maturity soybean, they flower at a different day length. They tend to flower a little bit later. That's why they're fuller maturity soybeans. These these beans were still alive when the weather turned in August. Again, I mentioned August 15th, August 20th, it started to cool. We started to get some moisture and really had some decent weather for grain fill. And what we saw was those fuller season soybeans were still alive. They had actually probably pushed maturity back a little bit due to stress, which soybeans can compensate for in the month of June and early July. And they were able to still fill pods and put on really large seeds. In terms of later planting dates, say we're planting late May, the data was pretty clear that those earlier season soybeans had a really big advantage. And I'm talking about the 1.8 to the 2.3, 2.4 type range, simply because if we're planting beans on June 1st, we need to finish. I just mentioned that the GDU accumulation really slowed. We had some early frost, and a lot of those fuller maturity soybeans did not finish nearly as well as those early varieties did. So it really depended on when you planted, but in general, most beans were planted early, and those early season soybeans, the 2.0 to 2.5 planted, in early May or late April, they were just far enough along that they couldn't take advantage of those really good conditions late in grain fill. And that leads me to one of my biggest recommendations, which is to spread maturity out. We can't harvest all of our beans on the same day anyway, or the same 3 days even. That's one thing we saw this fall. A lot of harvesting in soybeans gets done between 10 a.m. and 3 or 4 p.m. So it can take a while. If we plant all of our beans in a really tight maturity spread, not only are they subject to the same stresses, but it can also mean that by the time we get around to harvesting them, if say it takes 2 weeks and they've been ready for 2 weeks, we're going to start to lose some beans due to shatter. So spreading it out, planting some early beans and some full season beans can not only help your harvest order, but it can also help catch some of this better conditions if we get, again, next year, like we had the last 2 or 3 years, really nice late grain fill conditions. Another question I've gotten from, I think, everybody, and I've seen a lot on Twitter, is why were the edges of fields so poor in 2022? The answer is edge effect. It could be herbicide drift if you're maybe drifting an ACCase inhibitor from beans into corn. That's primarily what we thought this has been caused by in the past, but I think we've started to kind of reevaluate that assumption. So here's how I can best describe it. It's all about microclimate in these fields and in whatever's growing next to our cornfields. Air passes over these fields, right? So like a canopy of corn, and it's initially drier at that edge of the field, right? You've got drier air moving into the field. As that air moves across the field, it is going to pick some moisture up out of that crop canopy. So as it goes from east to west across the cornfield, the air will be much cooler by the time, if we've got a wind out of the east. At the east edge of that field, we've had wind move all the way across it, picking moisture up out of that crop canopy. So if we're on the edge, those more water is being used by those plants because of the dry air that's coming through and sucking more air out of that, more moisture in the air out of that canopy. So essentially what's happening is you're just having the edges undergoing severe drought stress that lasts all year because they are having to pull much more moisture out of the soil to make up for all of the moisture that dry air that hits the edge of the field is sucking up. And one of the reasons we see it be worse over, say, grass areas or soybean fields, alfalfa fields, even building sites is because that air is much drier. If it's coming out of a cornfield, again, as I just mentioned, by the time it gets to the end of that field, it's got quite a bit of moisture in it. That moisture air is going to blow into the cornfield next to it. So in general, we don't see the effect nearly as bad from corn as we do from beans, grass, alfalfa, things like that. Now, normally we also say we mainly see that edge effect on the west side and the south side of fields. And this year, it really didn't seem to matter which edge you were on. The north edge of fields were still primarily better, but I saw just as much damage on the east side of cornfields next to beans as I did on the west side. In terms of solutions, right, what can we do about it? Outside of dropping population along those edges and planting really drought tolerant hybrids if we know there are beans or alfalfa next to cornfields, I don't know that there's much we can do. One of the other big questions I got asked this year was why corn on corn was so tough in 2022. Well, there's a few reasons for that, right? And it was tougher last year as well, just not nearly to this extent. So if you go back and look at literature on corn studies from the 80s onward, it's not uncommon to see that there is a penalty for corn on corn, maybe a 5%-ish penalty. There have been some studies that have shown it could be as high as 25 bushels per acre deeper into a corn on corn rotation. But this year it was not uncommon to see it be 60 plus bushels off, right? So that's clearly a lot different than 5%. That's a lot larger of a penalty than we maybe see in a typical year. And in my opinion, there are a few reasons for that. So the first was soil nitrogen supply. If you think about corn on corn, over time, literature has shown it needs maybe 15 more pounds of nitrogen, roughly. Shouldn't be a surprise to anybody that we need a little bit more nitrogen going to corn on corn than we do following soybeans, right? That makes sense. Also, weather. Dry conditions limit how much nutrients are available, especially if we've had compaction issues and our root growth is restricted, or corn rootworm feeding can obviously affect that as well. And then residue. Residue affects disease pressure, it affects nutrient cycling, it affects how quickly that soil warms up in the spring. And as you think about the deeper you get into a corn on corn cycle, I think residue starts to become the enemy. Let's talk about nitrogen cycling for a second, right? So in the spring, nitrogen is immobilized as microbes start to decompose corn residue. This can happen in the fall a little bit if we get a timely harvest and we're still above 50 degrees. That's kind of the key threshold temperature for microbes. But this should be familiar to you. This is kind of fertility agronomy 101. We have microbes that need to eat to break down, and to do that, to break down carbon, they need to take in nitrogen. And it's tied up in those microbes. So it takes moisture for those microbes to start to break residue down, and it also takes, again, they're going to need some nitrogen. So let's think about this spring. We had a kind of a later harvest last year. We didn't get much broken down, and going into this spring, we were dry. Well, we did get rain in April and May. Actually, we had plenty of moisture this spring, which has kind of been rare. I know last year we were really pretty dry, but this year we did finally get some spring moisture. However, as I mentioned, temperature is very important. We need that soil temp to start to get above 50 degrees. And as you think back to this spring, we talked about in our first video, we had really cool soil temperatures throughout almost the entire month of April, with the exception of a few days where it warmed up. And then we really didn't start planting in earnest until the 12th through the 15th of May. So again, very cool soil temps well into May. We had a really hot week in there that was kind of unseasonably warm. But in general, April and May were pretty cool. And that means those microbes are going to take longer to break down that residue. And if you're in year 3 or 4 of a corn on corn cycle, you've got a lot of residue, you've got a lot of nitrogen that microbes can tie up. That makes that nitrogen not available to those early corn plants. We also could have had in central Iowa, where we had those really 2 large rainstorms in June, we could have had some loss due to leaching, and we also had some moisture sit on the surface of the soil long enough, and that soil be saturated long enough to maybe get some denitrification. All right, let's talk about weather a little bit as well. So say those microbes have broken down that corn residue, they die, then that releases that nitrogen, right? Mineralization, that's what we call that. So eventually the corn plant needs to uptake that nitrogen. And you can see here at the bottom, we've got a percentage chart of when corn starts to take in those nutrients, and this is for nitrogen. It really starts in earnest at V10 to V12, and then you've got that period of rapid uptake. Typically that's in July when we see that happen. So if we're dry, nutrient uptake is reduced because root growth is not going to be as broad and cannot explore as much space, and also we're getting less transport. Fewer nutrients are moving in that soil water into the roots because we don't have very much soil water. Potassium is one of the biggest ones that's soil mobile. It moves in the soil solution, and if there's not enough water, it can't get into the roots, and if our roots haven't grown and spread out, there's less root volume that can explore that water. And what were our driest months this year? They were July and early August. Again, that's where with later planting, some of our most rapid growth occurred. That was that V8 to V16 stage in July. And then in early August, we were in that R3, R4 window for soybeans, which is one of the most critical for yield. So most likely with that reduced mineralization of nitrogen and the stress plus dry conditions we had during July and early August, we aborted some flowers and pods, and we probably reduced some ear size. Um, and I think that all of these things could have contributed to corn on corn being as rough as it was. And then getting back to residue, as I mentioned earlier, residue is the enemy, and I'm going to talk about carbon to nitrogen ratios for a second, which is probably not something you hear very often, but microbes like that ratio to be about 24 to 1. And corn residue is a lot higher than that. That ratio is more like 60 or 70 to 1 compared to soybean stubble, which is 12 to 1. So what a carbon to nitrogen ratio of 60, you say it's 65 to 1, what that means is for microbes to break down corn residue, they're going to have to take in a lot of nitrogen. And if mineralization is slowed due to temperature or moisture, which this spring it was primarily temperature, that available nitrogen is not there until we get enough breakdown and those microbes start to die and decompose. How can we speed up mineralization? What can we do about this? Tillage can help break up residue, but it will not help decompose it. We've disproven that over the years. And getting rid of, so tillage can help break up that residue and bury some of it, which can help with our disease pressure. We think it's helpful with tar spot. We're just not really sure to what extent at this point. All right, learnings from 2022. In general, our summers are drier and warmer, and we're getting a longer grain fill period in late August and into September. So the question I asked to everybody is, are your crops still alive to take advantage of it? If we know we're going to suffer through some really dry months, only to have moisture and better weather come on the back half of grain fill, we need to plan our planting and start to plan our maturity spread in both crops around that. And this has become long enough for me to, I think, to call it officially a trend or maybe even a pattern, because the last 3 or 4 growing seasons have all kind of followed this same outline. In most places, we had similar rainfall as we did in 2021, but the timing of it was much less opportune. I've gotten that question a lot as well. I had the same amount of rainfall as I did last year. Why are my yields so tougher? Well, last year we kind of got an inch to half an inch every time we needed rain. About every 2 to 3 weeks, we got spoon-fed a little bit more moisture. Also, our soil profile was much drier in 2022 than it was going into 2021. We've essentially exhausted all of our soil moisture. The deep moisture is not connected to our upper moisture, and we really felt that effect this year. Another learning was that those earlier soybeans planted in mid-May had pretty tough grain fill conditions, and again, we talked about this earlier, stress at R2 leads to flower abortion, and stress in that R3 to R4 period causes pods to start to abort. We talked about this in the first video. Pushing the envelope on planting early, specifically corn, caused pretty big yield impacts at harvest due to compaction from field traffic, due to sidewall compaction, due to variable or delayed emergence. With soybeans planted early, yes, we may have a frost risk, but I think the reward of bigger yields is much more impactful and important. The data with corn shows that planting around April 15th, we're really not gaining any yield. That optimal window is more like April 27th through the 15th of May. I'm not sure that it's worth pushing corn into the ground that early in April, unless it's, we're very dry and the conditions look like they're going to stay that way, and they're going to be warm, because we can get by with an impaired soybean stand, or we can go out and patch seeds back in. We can plant at an angle and dribble 60,000 more plants out there, but we can't do that with corn. And if we mess it up from the get-go, we've just taken the roof off and the top off of that yield, and we have to lower our expectations throughout the rest of the growing season. Genetic diversity and diversity in planting dates spreads out weather risk. We kind of talked about that already. And lastly, it seems to me as management, like fertility or fungicide, paid dividends in 2022. And especially with fertility, I tend to think we maybe need to be paying more attention to our soil pH, to some of our soil tests, and just to our overall fertility plans. I know fertilizer prices are high, but it's still important that we have adequate fertility out there, especially if we're going to have some moisture stress. Last couple of things I wanted to show you is I pulled yield by planting date for corn and soybean through just some of our internal trial networks, as I thought this data kind of helps back up what I've talked about here today. And this isn't in chronological order, so I apologize for that. But based across all the trials from the state of Iowa that I pulled, I went and binned the planting dates into the categories that you see here for all the data that was in our system, and then averaged the yields. So this is across trait, across rotation. We didn't have any data from mid-April. No plots were planted prior to the 19th, but we did have some in June at the tail end. So what you see here is that early May, which I define as the 1st through the 12th, which there were not very many, let's put it this way, not every place in the state could plant that early, but we did start to get in around the 8th. We saw the highest yield in 2022 from that window, an average of 249. As we moved to late May, which I defined as the 23rd through the 31st, we actually saw the second highest average yield in our data. That's a surprise. You would think as we get later into May, we've already passed that yield penalty cliff of the 15th through the 20th, we would start to see more of an impact on yield. But again, pollination stress, like I talked about in that mid-May period, caused the average yield for mid-May to be lower than you'd maybe expect. And mid-May was that 13th through the 22nd was how I defined it. Late April, which we talked about, the stands were impacted by cool weather. That seed sat in the ground for a long time. We saw that show up. So if you would, that late April period was the 20th through the 30th. If you had waited, anywhere from 8 to 10 days, we're showing here a 29 bushel difference between those two plantings. And then lastly, June, no surprise that corn planted in June was the lowest yielding. As we look to beans, kind of a similar trend with the two highest planting dates being late April and early May. If you average those two together, we're pretty close to 70 bushels. As we get into mid-May, very high yield as well. And then with beans, this is what you should see. As we get later, as we get into late May and into June, we start to see those yields go down. Again, we know that planting soybeans early is going to give us the highest yield potential, and that's kind of what this data bears out. Thanks for watching all three parts of these videos. If you've made it to the end, I really appreciate your viewing. You can find us on Twitter at Iowa_channel. Thanks for watching, and we'll hope to do this again next year and talk about what we can maybe learn from the 2023 growing season.